In the Lesson 5.3 example, Is blood type like a card game? We'll review the concept of identifying binomial settings. Let's determine whether or not the given scenarios describe binomial settings, and justify our answers. For A, genetics says that the genes children receive from their parents are independent from one child to another. Each child of a particular set of parents has probability 0.25 of having type O blood. Suppose these parents have 5 children. Count the number of children with type O blood. Now recall, a binomial setting arises when we perform n independent trials of the same chance process and then count the number of times that particular outcome, which we'll call a success, occurs. To determine whether or not we have a binomial setting, we'll check the bins. What we'll do in this case is check to see whether or not we have 2 possible outcomes for each trial. We'll say a success and a failure. We'll determine whether or not those trials are independent. We'll see whether or not the number of trials is fixed in advance, and then we'll determine whether or not we have the same probability of success on each trial. In this case, we'll note that each trial consists of observing the blood type for one of the parent's children. Well, first we note that we do meet the binary condition. A success is defined as having type O blood, while failure is defined as not having type O blood. We note that knowing one child's blood type tells you nothing about another child's because each of them inherits genes independently from their parents. So the independent condition is met, and that was actually noted in our problem. Next, we note that we have a fixed number of trials in each case, n equals 5, because we suppose that each parent has 5 children. And then finally, the probability of success is the same for each trial, and that was given to us in the problem as 0.25. So, because we meet all 4 of the conditions, this setting is a binomial setting. Next, suppose we shuffle a standard deck of 52 playing cards. We'll turn over the first 10 cards one at a time and then record the number of aces we observe. Well, again, let's check the bins. And in this case, note that a trial consists of turning over a card from the deck. Well, we do meet the binary condition because a success could be defined as getting an ace, while a failure could be defined as not getting an ace. However, our independent condition is not met. If the first card we turn over is an ace, then the next card is less likely to be an ace because we're not replacing the top card on the deck. We would have had 4 aces to start with out of 52 cards. However, if we draw an ace, we now have 3 aces remaining out of 51 cards. So the probabilities are not the same from one trial to the next. Also, if the first card isn't an ace, then the second card is actually more likely to be an ace. So this is not a binomial setting because the independent condition is not met. For some additional practice identifying binomial settings, try exercise 1.